Tom here from FDS, and today's subject is simple LEDs. I've got to give a shout out to Lord of Clash, who's a fan of the site, for suggesting an LED video. And I'm going to show you a simple method that I use to install LEDs. Now, this isn't the most scientific method in the world, and you can make much more complicated rigs than this for multiple LEDs and for other things, but this is a nice simple method. So what I've done is I've mocked up a circuit, and I'm just going to go through the components of this circuit for you now. So we've got the positive main lead from the battery, the negative main lead from the battery, and then this is the LED wiring, and then you'll see there's a switch here, and this just happens to be the switch from a jam door, because that's where I wire my LEDs to, and I'll explain that in a minute. Now, if you're looking at a loom in a blaster, then obviously this would be your main battery plug, and you can see I've got a nickel metal hydride battery connected there, because there's a few uninsulated connections, and those are nice and safe if you accidentally short them. And I didn't insulate these because I'm going to take it apart in a minute, and that was just made from scrap. So in a strife, this would be your main power feed, which would go down to the rev trigger. In a rapid strike, this would be the lead that just goes into the trigger cluster to power the rev trigger and up to the main. And then the negative lead in a strife goes to the main motor negatives, and a rapid strike goes to the motor negatives, and then there's another one that comes back to the trigger group and feeds into the pusher control switch. So those connections should be easy to find. Now, all you need to do, you will need some tools. You'll need some wire cutters. Obviously, if you're wiring, you'll need wire cutters, and if you're wiring, you also need wire strippers, and I also use a sharp blade to make my splices. So what you will do is, obviously, you would start with your power source disconnected. You should never work with anything connected. So you should start with your power source disconnected, and you would strip off a little section of insulation on your battery positive and make your red wire. Remember your Britner standard wiring diagram. Red is for power feeds, 2 switches, so anything carrying power to a switch or to a component. Blue is a feed from a switch, and black is a negative. So you take a red feed, and that goes all the way into your switch with nothing on it. Look, there's no resistors, it's just unimpeded single wire. If you were going to run a voltmeter, then you could also put a voltmeter into this circuit, and I've shown you how to do that in my voltmeter install, and this is the LED component of that. You can do lots of things to make this circuit more interesting. You can have it as a, I have an accessory plug circuit often now, where I just have a JST connector connected in here in the line, and then you can plug and unplug your accessories, and you can change them however you want without touching the main loom. So that's always worth considering if you're a modular builder like me. So you have your red lead, and then your black lead also just patches in. I put it on the end because it was convenient, but I wanted to demonstrate both types of splice. You can see there's a simple splice into the lead where you just stripped off the insulation and then attached the two with solder, and again properly insulated that, and that's nice and strong. And you should never have any bare wire in any of your loom showing, because you can get a short, especially if you're a LiPo user or any pack. You want to avoid any bare bits of wire. So you'll notice that nearly all of this is insulated. So when you've wired your switch and you've got your red power lead to the common, you then need to take your normally closed blue lead, and you need to go to a resistor. Now, the easiest way to do this is just to get a 470 ohm resistor. I picked 470 because it covers 2S and 3S. If you're going to go 4S on this, you would need a little bit more. You can go up to 1000 ohms or 1K, and all that will do is dim the lead. Remember, if you've got a 470, you can always put another 470 in series, one after another, to add up. And I use the 470s because they do 2S or 3S, and they produce still a reasonably bright light. Now, this is a red LED, which isn't the brightest. So what you do is you take your power lead into the common on your switch, and then out of the normally closed, and then you can see that goes to a resistor. So with this single resistor, you can run multiple LEDs. You can run up to 4 off of the one resistor. Otherwise, you get too much load through them, and you'll need to have additional resistors, because obviously you don't want those getting hot. And if you try to put too much current through them, they'll shed the excess as heat. So what you can do is you can now wire multiple LEDs into the circuit. Now on LEDs, they're a diode, so current only flows in one direction. And what you've got is the longer leg here is the cathode, and the shorter leg is the anode, and that means that the positive goes to the long leg and then the negative goes to the short leg. If you want to cut these down, cut the negative first and then cut the positive a bit longer, and that way you always maintain your circuit being around the right way, because a diode will only allow current to flow in one direction, unlike a bulb where it can flow in either direction. As we can see there, unbalanced a bit. There you go. There, so you can see that I've just added another LED there in parallel, and you can keep wiring them on. So you can have multiple ones. If you wanted to spread them out a bit, you can just put some wire tails and then just wire them on as you go along. And so you can chain them along you can have up to 4 off of that one resistor. So if you want to put more on, then you'll need additional resistors. So that's a 470 ohm resistor, and then all I've got then is just a negative which just goes back to the main battery negative in the blaster. If you're putting this circuit into a blaster which doesn't have a battery, like a Springer, you can just use a little simple coin cell, and that eliminates the need for a resistor, because a coin cell is usually 3 volts. You might need a very, very low resistor in there just to drop the voltage a little tiny bit. There are calculators online, so if you look up resistor calculators for LEDs, there's a couple of good ones that will allow you to do that. And that is essentially all you need to make for these. And that gives you a simple switch that stays off when the blaster's jam door is closed. The minute you open the jam door, it comes on. And that is basically all you need to install LEDs in your blaster. So hopefully that explains how I do those.